Assalamualaikum warahmatullahi wabarakatuh. And my name is Nick Muhammad Amiruddin bin Azrat, and my metric number is DA220179. Okay, today I will construct our group circuit by using multisim. Firstly, for the guidance to make the circuit, we must use this circuit, which is have two source, capacitive impedance, inductive impedance, and industrial load. For the value for source 1, source 2, capacitive impedance, inductive impedance, and industrial load, we are using the value that has been given, which is for our group is group number 2. Okay, firstly we must put two. For the component, we must put two power source, and then we must put two resistor, and then we must put two capacitor, and then we must put one inductor. And last for the last component, we must put ground, and then we must connect all the component. Okay, for the value C1, C2, and L1, we must change first because the given value, which is XC and XL. Okay, for the XC, we are using the value, the formula is which is XC equal to 1 per 2 pi FC. And then for XL, we are using XL equal to 2 pi FL. XL. Okay, and then we must change the value, and then we will get this value, which is capacitor is for capacity C1 is 63.66 microfarad, and then C2 is 212.21 microfarad, and then for the inductive we will get 143.24 microhenry. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Hafiq bin Muhammad Masanafi, and my matrix number is DE220175. So for today I would like to show you my part for this project on task 3, which is task 3 circuit implementation, and I will be doing on this question. Question C, I or 1 Roman, obtain VT and IT for the capacitor, inductor and load. So first of all, we need to know that Vt and It is the value of time domain representation. So here I need to obtain the value of time domain representations of the capacitor, inductor and load for this circuit. So first of all, we need to open up our multisim, and we need to build up our circuit based on the circuit provided to us for this project. So first of all, we need to make sure all the components needed are being put in the multisim. So our circuit consists of two source, two capacitor, two resistor, and one inductor. Okay, and don't forget our ground. Alright, so these are all the components needed to build up our circuit based on the circuit provided to us in the report or in the question. So first of all, we need to adjust the positions of the components. So this for the load, this for the load, this another one resistor, our inductor, our second source, and our ground. Okay, so after we adjusted the positions of the components, we need to make the connection of the components. Okay, make sure the connection is right so that the value obtained is correct, and we can run the simulation correctly. Okay, resistor to capacitor, is it? Wait a minute. just to make sure that it is connected. Okay, so after making the connections of the components, secondly, we need to make sure the value we inserted in the circuit is correct based on the table provided to us. What I mean by the value provided to us is that on here, as you can see, this is the table provided to us, which is table 2, information of sources, impedance lines, and industrial load. So for our group, which is group 2, we need to use these values given: 240 with 0 degree, 30 with 10 degree, and so on. We will use this value in our circuit after this. Alright, so for the first source, we are using 240 VRMS, and the frequency is 50 Hz according to Malaysian frequency. Our phase is 0, our AC analysis magnitude is 240, and our AC analysis phase is 0. And for our second source, we are using 30 VRMS, the frequency is 50, and the phase is 10. Then our AC analysis magnitude is 30, and our AC analysis phase is 10. Okay, that's for our second source. For our capacitor, the value given to us in the table is negative J50. So from this value, we need to convert it into the C value, which is the capacitance value. So because the given value is in XC value, right? XC. So from XC, we need to convert into C value. We are using the XC formula, which is XC equals to 1 over 2 pi FC. Using that formula, we can obtain our C value. So by using the formula, the C value obtained for the circuit is about 63.66 microfarad. Alright. Okay. And our resistor for the load is 10 ohm. Our capacitance value in the load, for capacitance value at the load is given to us is negative J15. So from this value, also I've stated before, we need to convert it into the C value by using the formula of XC equals to 1 over 2 pi FC. So by using that formula, the value C, or the C value obtained for this capacitance, for this capacitor is 212.21 microfarad, right? And for our resistor, another resistor, we are using 15 ohm. And for the inductor, given to us is J45. J45 is the XL value. We need to convert from the XL value to L value by using the formula of XL equals to 2 pi FL. So by using that formula, the value of L obtained is about 143.24 millihenry. Don't forget. Alright. So after all the values have been inserted in the circuit according to the from the value provided to us, make sure all the value is correct, the connection is correct, and then we click on active analysis, go to single frequency. Okay, for the frequency we are using 50 Hz like stated before, which is the Malaysian frequency, or you can just click on the auto detect and make sure you click on this box here, frequency column, right. And for the complex number format, we are using magnitude and phase. Why we are using magnitude and phase instead of real and imaginary? Because of the question need us to find the value of time domain representations for the load, capacitor, and inductor. So by using the magnitude and phase, from the value obtained from the magnitude and phase, we can insert it into the time domain formula, which is for voltage, we are using Vt equals to Vm cos in the bracket of omega t plus degree, and for the current, we are using It equals to Im cos omega t in the bracket, It equals to Im cos in the bracket of omega t plus degree. Okay, that's the reason why we're using magnitude slash phase instead of real and imaginary. Okay, for the output, here, sorry for my voice, we move first. We start from okay. For the output, we need to find the value required for us to find our value. We need to put all the variables needed in this box here on the right side is the value we need to find for the questions, which is the value of time domain representations, the value of time domain representations for the load, capacitor, and inductor. So from the left box here, this the variables we need to move it to the right box. The variables from the left box will move to the right box, which is for the variables in the right box is the variables that we need to use in order to find the value needed to fulfill the questions of VTIT, or the questions of 1 Roman, which is to find the value of time domain representations of the inductor, load, and capacitor. Alright, so here we add IC1, IC2, IL1, V2, and we add expressions of V1 minus V2, and another one is V3 minus V4. Okay, let me explain to you. For IC1, the variable of IC1 is the variables that we use to find the current for this capacitor, C1. And for IC2, we use to find the current on the capacitor at the load, here, C2. And IL1 is the variable we need to use to find the current on this inductor, L1. And for V1 minus V2, we use these variables to find the voltage across this capacitor, which is V1 here minus the voltage from here side, from this side. So V1 minus V2, we can obtain the value of voltage for the C1. So V2 is the load voltage, which is for this load here, right here. And V3 minus V4, we use this variable to find the value of V for L1. V3 minus V4 to find this value, alright? V3 minus V4, yeah. We use V3 minus V4 to find voltage for L1 here. Okay. So, we click run. Okay. This value obtained after we set up the parameter just now. So, okay, for V1 and for IC1, which is I stated before, IC1 is used to find the current for C1 here. So the magnitude we obtain is 3.72 and the phase is 77.25. And for IC2, which is current at the load or the capacitor at the load, we obtain 3.97 and the phase is 91.30. And for IL1, the magnitude we obtain is 973 milli or 0.97, phase negative 20.65 for our inductor. And for voltage for our capacitor V1 minus V2, we obtain 185.94 and the phase is negative 12.75. And for the V load or load voltage here V2, we obtain 71.59 for the magnitude and the phase is 34.99. And last but not least, the voltage for our inductor, which is V3 minus V4, the magnitude is 43.80 and the phase is 69.35. So I've stated before, from this phasor value, from this phasor representation value, we can obtain our time domain representations. If I can show you my slide here. Okay, as you can see, this is the time domain representations of our load, which is Vt equals to Vm cos omega t plus degree. Okay, for the value for our load voltage, if I can show you, sorry. So for our value for our load voltage, we obtain from our past calculations, which is here. Here, our load voltage, or we obtain from here V2 here. V2. This from the calculation, this for the measured. My mistakes. So for our load voltage, V2 here is 71.59. Okay. So as you can see in the slide I've presented to you just now, this is the voltage time domain representation, 71.59 cos 100 pi t plus 34.99. Okay. So for information, the omega value we have options. One, omega equals to 10, or omega equals to, another one is omega equals to 2 pi f. So here I've used omega equals to 2 pi f. That's why you see I obtain 100 pi t, which is 2 pi multiplied by 50 hertz, which is the measured frequency. So as you can see, this is the voltage of our load in time domain representation, 71.59 cos in the bracket 100 pi t plus 34.99, and the current load or the load current in time domain representation is 3.97 cos in the bracket of 100 pi t plus 91.30. And for our inductor, the voltage for our inductor in time domain representations is 43.80 cos in the bracket of 100 pi t plus 69.35, and the current is 0.97 cos in the bracket of 100 pi t minus 20.65. And last but not least, the capacitor we obtain for the voltage is 185.94 cos in the bracket of 100 pi t minus 12.75. And last but not least, the current is 3.72 cos 100 pi t plus 77.25. And I think that's all from me for my part. In question C, 1 Roman, which is to obtain the value of Vt and It for the load, capacitor and inductor. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. And hello everyone. So my name is Muhammad Aris Hakim bin Muhammad Fadusi. My number matrix is DE220118. Alright, today I'm going to talk about how to find the voltage and current value in the phasor for the capacitor, for the iLoad, and also the inductor. Alright, first we have to build the circuit. So this is the circuit that I have built, and then we just choose the simulate, and then we choose analysis and simulation. After that, in this column, we just choose the single frequency AC. We choose the auto detect for it will choose the highest frequency. So in the complex number format, we will just choose the magnitude and phase to find the phasor. Alright, so for the output, we just choose which part we want to find. Okay, so you can see IC1 is for the current for the capacitor. IC2 is current for the iLoad. IL1 is for the current for the inductor. Okay, so for the V1 minus V4 is the voltage for the inductor. V2 is voltage for the iLoad. For the load, V5 minus V2 is for the capacitor. Okay, so we just add these variables from these sides to these sides. For the V1 minus V4, we just can build the expression by choose this add expression, and we just choose which variable we want to add. As example, we choose the IC1, we choose the function, and then choose the another variables, and then just click OK to add it in the variable for analysis. But I have done it. Okay, so now we just run, and then it will shows the magnitude and the phase. Alright, so this is the V1 minus V4 is the voltage for the inductor, which is the magnitude is 43.8. The phase is negative 110.64, which is in voltage. Alright, this is the voltage for inductor. For the current for inductor is this one, IL1, which is the magnitude is about 973 milli. The phase is negative 20.64 ampere. So next is the V2. V2 is for the load, voltage for the load. So the magnitude is about 71.58. The phase is 34.987 in the voltage. Alright, for the current, this is the one for the iLoad. Alright, so the magnitude is about 3.97 and the phase is 91.29 in ampere. Okay, last one is the capacitor. So this is the voltage for capacitor, which is 185.93. The phase is about negative 12.75 in volt. So the current is 3.71. The phase is 77.24 in ampere. Alright, that is all for me. Thank you.
Okay, for C3, apply the load with Zmax. For our Zmax, our RTH is equal to R2. Our RTH is 150 ohms. So to get the peak magnitude of voltage and current, we can use oscilloscope. Okay, for oscilloscope, this is our clamp to get the waveform of current. So we put channel B for current, ampere, channel A for voltage, and run. This is the waveform we get. Okay, for the scale, we use 20 millisecond because we use 50 Hz. So our channel A is voltage. This is T2. So we can get the VP is 455.749 volt, and our I peak waveform, I waveform is 3.013 ampere. Okay, for the power is we can use single AC frequency. So single AC frequency output, and we use expression PR2 plus PC2, and we get the value of the power for Zmax. Thank you.